Good day, grade 11 students. Today I have a child of trigonometry here, and that is three graphs from November 2016. Speaking from the advantage point, this question seems not to have too many shifts in the kitchen, so I guess it was too easy to swim and fish in a clean pond. Let's see how. We have question 6 just right here. They are saying in the diagram, the graphs of f and g are drawn for the interval that is from negative 180 to 90 degrees. Okay, so now let's analyze this graph of f and g. So we are given f here, which is equals to the cos of x. So basically, they are giving you what? The mother graph of the cosine graph. We know this from grade 10, that if you don't see any coefficient of the angle, even the vertical shift like plus q or minus q, this is going to be described as the mother graph or the parent graph of the cosine. So that is given to you, and you're also given g, which is g of x equaling to sine of x plus b, where this b shifts the parent graph of sine horizontally to the left or to the right, okay, of the x-axis. Let's check these graphs here. I'm gonna underline them. Let me just really enlarge this. So the cos graph is possibly this one. That is the graph of f that you are given. And then now you're also given the graph of g, which is this particular one there. Okay, so now check. They say to you, write down the value of b. So the value of b shifts the graph of sine horizontally to the left of the x-axis or to the right of the x-axis. Now pay attention. I'm gonna really draw this g graph here. So that is the graph of g. What I want you guys to observe is that this graph, we have the parent graph of it, okay? So the parent graph of it really, it's sit comfortably at the origin. So now this graph is shifting to the left of the x-axis by how many units? So the units is basically the number that is sitting comfortably at here, and in this case is what is 30 degrees. Okay, so that means your b is going to be 30 degrees, and be careful here because you are shifting to the left. The value of b is going to be positive. If we're shifting that to the assume that this graph was sitting comfortably at positive 30 degrees, it means that your b will have been negative 30 degrees. So now that we are sitting just right here at negative 30, that means we are moving to the left from the origin by 30 degrees. So I'm gonna say that question 6, just trying to answer this question for you. Question 6, let's answer it together. So 6.1, write down the value of b. So b is going to be equal to 30 degrees because we are moving from the origin to the left of the x-axis. Okay, that's how you get that. You get 1 mark for that. Hey, 6.2, they say write down the period of g. So look at g. Your g here, let me pen this thing down. So g is equals to sine of x plus 30 degrees. That is the graph of g. Now pay attention. Hey, the number that multiplies x, or the coefficient of x, is basically going to affect the period of the graph of g. In this case, we have a 1 here. So that one is going to divide the complete period of the sine graph, like 360 divided by the number that multiplies this coefficient. Even if that number was sitting here, like assume that it was 2 here, it means you're going to say 360 divided by 2. But because we have nothing, so we assume it's 1. Okay, so we say 360 divided by 1. That is this 360. So to answer this question, I will say that the period is equals to 360 degrees. You get 1 mark for that as well. Hey, think about it. and then you have 6.3. They say write down the values of x in the interval, this interval here from minus 180 degrees to 90 degrees, for which let's just really copy that down, for which f of x minus g of x is going to give us a young zero. Now, if I were you, I'll try to manipulate this equation and say this is the same as f of x equaling to g of x. Always make sure that you transpose either f or g to the other side of the equation. Okay, now check. This simply means what is the point of the intersection of the two graphs. Now I'm going to interpret it from this particular graph right here. Now pay attention. I'm going to check where are these two graphs equal. These two graphs are equal there. Let's call that point A, and they are also equal at this particular point. Let's call that point B. So they want the values of x at A and B basically. So you're going to say that therefore x is equals to minus 150 degrees, or x is equals to positive 30 degrees. That's where the two graphs are equal basically. Okay, or that's when you minus their y values, you're going to get a zero. It's the same thing. So it is best that you interpret in this particular way. Okay, it's my advice, by the way. You can do it in whichever way. Now 6.4, for which values of x in the same interval which is minus 180 to 90 degrees, is sine of 90 degrees minus x bigger than the graph of g. So now pay attention. You have a sine of possibly 90 degrees minus x is bigger than the g of x. Now what I want you guys to pay attention here is that look at this thing. You guys know what is this, eh? We call that co-functions identity. Okay, so that in a sense of justice is the same as cos of x. This part here, it's called functions identity. Okay, so that is that's the cos. This basically is in the first quadrant, and then you now negate the co-ratio of sine, which is cos. Okay, so these are your identities, and then bigger than the g of x. Now what was this? This was given as the f. So basically you are looking the values of x for which let me just delay this, for which f, because this is f from the graph, is the cos, for which the f is bigger than the graph of g. Now check it on the graph for which values of x is this graph of f above g. What I want you guys to see is that this is f right there. That is your f, and that is your g. So that is the only time where f is above g. Bigger than means above g. So in this region here, the one I'm trying to shade now, that's the only region where the graph of f is bigger than the graph of g. Okay, that's the only region. So you need to read the values of x in that interval. So you're going to say that therefore that is from negative 150 exclusive, because here it is also exclusive. Okay, so from negative 150 to 30 degrees. I'm going to write negative 150 degrees. It is in between, it's in that region. Okay, in 30. Outside that, it's x less than yes, it's x less than minus 150 or x bigger than 150. So here they want where x is bigger than the g. So it is in that region, this particular region here, it's in between. Okay, yeah, let me just write my a there and my b for point of intersection. Now the last question, this was too short. The last question, the graph of h is obtained by shifting f 3 units upwards. Determine the range of h. So now pay attention. The graph of h of x is obtained by shifting the graph of f. So what is f? So we want to shift f, okay, 3 units upwards. I'm going to put a 3 for upwards, plus 3 is for upwards. But what is h? What is f? F is cos of x plus 3. So basically here, they are looking for the range of cos of 3x. Now, pay attention. What is the prescribed range of cos x? We have y bigger than -1 but less than +1, okay? So now this value here really affects your range. Think about it. You're going to have a -1 and then you add that 3 there and you say that is less than, less than y, and then y, y is bigger than that number then, but less than this one. You add 3 basically to both sides of that inequality, and then this really will ties down to +2. Y is bigger than 2 but less than 4. Okay, and this you can write in the interval notation as what? Let me just write, or you can write y it is in between 2 and 4. That's how you go about this particular question. And thank you very much for watching. Don't forget to follow and subscribe to my YouTube channel. Thank you.